Before we jump into all of the slides, I just want to point out and give some recognition to Lee Jasper. He has done a lot of the mission definition EATs before, and last week at your EAT, you were introduced to some fundamental system engineering ideas, and one of those was the systems engineering. Just to kind of give us an idea of where we are today, we're in that red area, the mission definition EAT. Coming next week, you're going to get another element of systems engineering, so part 2, and then a third systems engineering, the purple there, and then a lot of the other EATs will essentially cover what's green in that V. So we're in the very beginning stages of that V, helping define, what is the mission you're about to go do, and how do I approach some of those things. The goal for today is to really walk you through some of the high-level considerations, and then in some of the future EATs, and I'll point that out as we go along, you're going to get even more detail on how to approach those. So what is mission definition? Generally speaking, mission definition is a process where stakeholder needs and expectations are identified and turned into a mission statement, the high-level objectives, the goals, the success criteria, and your requirements. And ultimately, what you're doing here is defining what is being done and what is mission success. So the first part, what is being done, why do we exist? And then what is mission success is really addressing that question of when are we done. As engineers, there's that idea of trying to improve forever. Mission success really tells us, okay, this is when we can stop. This is when it is good enough to move forward and finish this. Another way that I also like to think of mission definition in the very high level is really thinking about what do you want to be able to say at the end of this. So what are we learning? What questions are we asking? And how is that learning going to be used in the future, maybe in your laboratory or with other stakeholders that you have? So kind of keeping in mind those really big picture questions of when are we done and what are we trying to say at the end of this are good vectoring questions as you're working through the entire process. Now that first definition calls out the idea of a stakeholder. And this was introduced also in the previous systems engineering EAT, giving you just kind of an idea of what a stakeholder is. For your purposes, it will often be your lead professor or the head of the lab or any other person or group of people who are interested and or driving the need for the mission's data. Stakeholders can also be people maybe within your university who are placing constraints on how your mission unfolds. And so mission definition is a conversation with your stakeholders to, again, figure out what are we doing, when are we done, and what are we trying to learn. If you want to dig really deeply into this idea of mission definition, just a few references for you. Of course, the UNP User's Guide is always a great starting point, but then also the NASA Systems Engineering Handbook and NASA Systems Engineering Processes and Requirements, and of course SMAD. Those are all great places to have some regular references that dive into all the details of how do I go about mission definition. On to the next slide, please. So great. It's this idea of what are we doing, when are we done? A question that kind of comes up often is this idea of, well, we submitted a proposal for UNP, aren't we done at this point? And the answer to that is really only partially. So first of all, proposals might not have all of the elements that come up in typical mission definition. And also what you're going to see as we're walking through this is that it's really an iterative process. So your proposal might have been the first cut at pulling together a mission definition, but you're going to be going through that process over and over again as you get deeper into the design process and new requirements are revealed, all of those other pieces. So don't look at this as a one-time thing that you just do it once and it's over. This is something that's going to kind of carry through the entire process. But with that in mind then, what are you trying to get out of it? From a technical viewpoint, it's really about defining what is challenging, what will drive your design the most. It's about convincing yourself and the stakeholders that the mission is both possible and how it is possible. And then it's really outlining specific metrics that the team you can evaluate against to know when the design is acceptable. Again, those mission success criteria that are really going to tell you, when am I done and did I accomplish what I was trying to do? And a lot of cases, a good thing to keep in mind with this is better is the enemy of good enough. There is a lot of incentive sometimes, to add every single thing into it. And mission definition is that process of really evaluating what do I really need, what is good enough for this moment so that I can learn something important and go on to the next step or learn the next thing I need to learn. Mission definition is also going to pull in this idea of constraints, and these can be programmatic constraints or technical items that essentially bound the mission, what you can do. Typical ones might be schedule or cost. You might have specific ones within your university framework, but it's also pulling those pieces out to understand, what's in bound for what I can do. And as you're working through this process of mission definition, then for UNP, the end product really here that shows the results of all of that work is the mission design document or set of documents, depending on how you break it up. So that includes things like the mission overview, the experiment plan, and the concept of operations or ConOps. And so all three of those together give you this convincing argument that the mission that you're doing is important and worth doing. It has some of those above elements we just talked about, and then might address some of the other programmatic attributes, although some of your other UNP documentation might cover that, such as your staffing plan, roles and responsibilities, things like that. One thing I want to circle back to as we're dipping into everything, during the kickoff, I'm sure they went through, all of the upcoming milestones and reviews for the University Nanostat program. I want to go back to that second sub-bullet of convincing yourself and stakeholders, and just kind of pointing out here that I really want to emphasize this is also about convincing yourself, your team. This isn't just an outward expression of what you're doing, but this is the way you are convincing yourselves. So that is a big piece of the mission definition. How do I start kind of doing this? What's the approach that I take? So I have a general idea of what is mission definition. How do I go about actually doing it? At the last Systems Engineering EAT, this flow from the NASA Systems Engineering Handbook, I believe, was introduced. And it gives you those general guidelines of how to start breaking down the process of mission definition. And the flow, I think, from the outside looks really simple, but it's important to note that the reality of this can be a little bit messy. There's often going to be instances where there won't be one right answer. You'll have to make a choice. You'll be making trades. And so as you're kind of getting into the weeds of actually doing what it says on here, you're probably going to see a lot of back and forth. So what we're going to do for the next little bit is really just step through this a little bit and give you some basic considerations as you're breaking down the different elements of this flow chart. And again, just to kind of recap the big picture of it, starting off in the mission definition, it's really going after those stakeholder expectations, which then allow you to form mission objectives and constraints, pull together your experiment plan, your success criteria. And once you have that first idea, you're flowing into your high-level requirements, starting to think about, what does this mission really look like in terms of how to do it. And so we're now kind of getting into loops that look at the design drivers, additional requirements, ConOps. If you're going through that process, you're kind of assessing, is this going to work? And you can see that there are several loops here. So again, you're going to be passing through this and perhaps multiple times. Go ahead and go to the next slide. Just a quick note, your team should have gone through this loop at least once and have that first baseline. You might already be in a place where, you've gone through it a couple times. So, how do you go from flowchart to actual answers? The first place I would recommend starting is reading your team's proposal if you haven't already, or if your team already has a starting document about, what is your mission about, and then begin that conversation with your stakeholders. And as you're talking about what was proposed, what your stakeholders are trying to get out of this process, it's going to allow you to take a first pass at creating a mission statement, a mission objective, mission success criteria, and again, identifying any constraints that might be there. These statements altogether are the core statements that you're going to use throughout your, UNP time to help your team and others understand what you're actually doing. So for the mission statement, that is a broad multiple sentence statement of the entire mission's purpose. And it's usually going to focus on scientific or technological goals of the mission. As it says there, that's really the mission's elevator pitch. So this broad statement that gives people a sense of what are you about. And from there, you're going to start narrowing down to objectives. So here we see the definition from SMAD, broad statements of what the system must do to be useful. So we're starting to get a little more detail here. And then that's going to flow into mission success criteria. So objectives are going to state what the system must do. Mission success criteria state how well the system must do it. These are specific and quantitative in a way that you're going to be able to assess pass-fail criteria, and really taking that opportunity to say, yes, we know what whether we accomplished what we set out to do or not. Also, as part of that process, again, looking for constraints. So any conditions that are to be met. UNP places certain constraints on your missions and how they flow out. So when you read through the user's guide, you will pick up some of those constraints. All four of those together give you those big picture statements. And again, you're drawing those out from your conversations with your stakeholders and your team's proposal. As you're going through that process, sometimes it's helpful to have some focusing questions. So again, the proposal is there, but what you really want to do is have a conversation with your stakeholders to really talk about why were they interested in doing a mission, or why is your team interested in doing this mission. And so these boxes here just kind of give you different types of questions that you can ask. In the blue box on the left here, there might be some science questions that you can ask. What is the question you're trying to answer? What is the nature of the demonstration you want to achieve? What do we already know about it? What work has been done before? How can we bring that into what we're going to do? What do the physics of the question tell you about how you might answer this question? So all of these are just kind of examples of things you might do to kind of pull different threads out in the conversation about what are we trying to really get after, where are we going to get the most value from, what really absolutely has to be done. Just to point out a couple other ones, the gray box down below that's talking about technology options. So here, just really emphasizing this idea about options. How many different ways could we potentially accomplish what we need to? What are the different TRLs, technology readiness levels, we might need to think about as we're throwing out options. So lots of different considerations here. So as you kind of go through these questions, you're going to start to get answers to help you fill out, what is our mission statement? What is our set of objectives? What are our criteria? A good follow-up to all of these questions is, of course, why, right? Usually the first answer will be there, but they might be assuming a certain reason, right, for giving you that answer. So always follow up with the idea of why is that answer the way it is? And the answers you get from the why question are also going to tell us about constraints you might have to look out for, or requirements that you have to build into the system, or even setting priorities in our mission success criteria. So having that idea that some things are going to be more important to your stakeholders than others. So use why liberally as you're kind of thinking about that process. We have the framework. We know that ultimately, as we're going through the process of mission definition, we're trying to get to our main statement, our objectives, our success criteria, constraints. We have questions to help us kind of have the conversations that we're interested in. But there is this bigger piece too where, although we want the mission objectives and success criteria, what I would say is those are necessary but not sufficient. There's a whole story behind them. And the way in UNP that we tell that story is the mission design document set. And so that includes the mission overview, the CONOPS, and the experiment plan. And what you really need is all three of these pieces to give the full background of the who, what, when, where, and why of your mission. So let's kind of talk about what each of those are and then go back to why this is so important. So mission overview, again, pulling from the UNP User's Guide, this is an expression of the intent of the mission. It's going to include a high-level introduction to the mission. It might give some background on why this is important. As you're advancing in your design, it's going to give you a little bit of information on the supporting satellite system, and it's going to always include those mission objectives and the minimum and full success criteria. So the background information, but then also those focus statements that people can go to time after time to understand what you're about. Then we have the CONOPS and the experiment plan. So I'm going to jump down to experiment plan first, again from the User's Guide. This is really a discussion of the experiments that will be performed. What are you measuring or doing? What's the goal or the final result that you're expecting? Is there an order to the experiments you're doing? Is there a particular configuration that you need to be in? It's kind of all of the considerations that you're going to be thinking about to answer fundamentally the question that you're after. But paired with that is this idea of CONOPS, or concept of operations. So the CONOPS are really the process and the procedure by which the fully developed satellite will fulfill its mission. So I personally like to think of the experiment plan as a little bit of the what and the why paired with the mission overview, and the CONOPS is really focusing on the how of it. And so it's all three of those. You can't take any one of those totally by itself and have full understanding of what you're doing and why you're doing it. You really need to kind of view all three of those together, and that's why they're grouped as the mission design document set in the UN terminology. The reason why it's important to kind of think about how you're going to approach these documents and be thoughtful about the content that you put into them is going back to the systems engineering EAT from last week. You know, the difference between verification and validation was discussed. The MDD, as that EAT pointed out, is the tool that you will use to validate your efforts. In other words, did we build the right system? And so this is your way of kind of expressing, you know, are we going after the right things? And this is especially important, you know, as your kind of core set of information, the documentation that you use, as you're considering options down the road. Maybe you have to go through a D-scope, or just even the general experience of student turnover. These are going to be the core statements that really let everyone know this is why we started this process in the beginning. This is our reference point for really understanding, are we still on track despite any design changes that might happen, or, you know, trying to bring people up to. When am I done with these documents? Your proposal that was submitted to UNP might have already tackled, again, a huge portion of this, but there might be different elements there. What this is really kind of showing is just this larger discussion of where are you spending your time and your focus. So in the beginning, there is maybe a science question that you want to answer, or there's something that you're trying to learn. And so the focus around what is my experiment is high. You can see that with the blue line there. And then as you're kind of asking, what is that question I'm trying to answer? Again, maybe it's a science question, maybe it's a technology demo. Around that forms this idea of a mission, your mission statements, and that ConOps. And so you can see that starting to creep in after the initial formulation of what idea or what question am I trying to answer. So over time, your experiment plan, you'll spend less and less focus potentially on that. ConOps will kind of increase, but these things are going to maybe flex a little bit over time as you go through different elements. So maybe you're doing feasibility studies, maybe you're getting deep into the design process and realize that some of the components you were looking at aren't going to work for one reason or another. As you're going through testing phase, new results are kind of cropping up, and you're going to see adjustments to documents as they go on. They're going to get smaller over time, but these are kind of living documents as you go process. They're not just done immediately after you finish your. So kind of keep that in mind too as you're going through the process. As you're doing the first round of your mission design documents, the overview, the ConOps, and the experiment are going to help you draw out what are those mission objectives, area in the. So the next area that we'll kind of dive into, now that we have some initial thoughts on maybe what we need to do, is digging into the how a little bit more. Starting with design drivers. The flow chart that we saw has a couple different elements: design drivers, off-ramps, requirements, and ConOps. And so we're going to, again, just talk through some high-level considerations. Those are going to happen in an iterative process, and so you might see design drivers as you're talking with your stakeholders. Some of it might come from UNP, some of it might come from just the nature of the science question you're trying to answer. But in general, a design driver is an element of a mission that, in order to be accomplished, forces the rest of the design to morph and accommodate that element. So a very classic example is the CubeSat form factor is a design driver. So in UNP, you have to stick to the CubeSat form factor, and so you have to make sure that everything you're planning fits the dimensional and mass restrictions of a CubeSat. And that is going to drive lots of design choices for you, and you can see, different. Understanding those design drivers is going to help you focus the architecture, the main elements that require specific attention. And that's important because if you have to kind of go through some design iterations or consider different options, you can really think about how much the design drivers you're choosing are really imposing difficulty or simplification on your process, all of those different pieces. So a couple different categories here when you're thinking about design drivers. Obviously, it's easiest to often start with the experiment or the technology demo. This will often include some drivers, and we have an example at the very end of a former UNP project that kind of gives some examples. Other common small-sat drivers are going to be the swap, the size, weight, and power. Sometimes it'll be thermal, other things like data rates. And then again, each mission out there might have case-by-case and drivers that crop up. Understanding the drivers are the key details you want to focus on by your system concept review, SCR. So you don't necessarily need to be all the way in the weeds of every single component and having that detailed, but what you really want to understand are what drivers are present and how is that maybe starting to inform what trades you have to make and how is that acting requirements, things like that. Drivers are really things that you want to be thoughtful about as you're preparing. Off-ramps is another category to think about. So as you're kind of stepping through the process of mission definition, but then also getting into more detailed design, it might become apparent that the solution you've been working towards is either too difficult, maybe it's too expensive, time-consuming. And so what you want to be thinking about are off-ramps or alternatives that you can use. In many cases, when off-ramps happen after the fact, these are not often ideal solutions. So maybe you won't be able to meet full success criteria. Maybe it will be a reduced set of them. When you can, it's great to be able to identify off-ramps early in the program. That helps for quick revectoring as you're getting deeper into your design trades. When you're thinking about these, often you need to be maybe a little bit creative in how you think about it. One of the things that I like to point out is that the value of talking about off-ramps early on rather than just addressing it when you're kind of forced to because you find out there's a problem is that it really opens up the discussion of whether or not there are other ways to accomplish the experiment or the ConOps. Often, after we have our initial stakeholder conversations, you can kind of get into a mode where it's just, I know exactly what we're going to do. This is how it has to be done. And now, as you're in, your pre-system concept review stage, it's really the time to question, is that really the only way to do it? If I couldn't do it that way at all, how else would I do it? Or what could I do that would maybe get me there part of the way, but not all of the way? And through that conversation set, you might be identifying off-ramps for the future, but you might also, as part of your preparing for system concept review, identifying easier or simpler ways to approach the problem, or maybe you're pulling out a driver or constraint that prevents you from using any other options. And the better that you can articulate all of that in terms of why you chose the solution you can, it kind of sets the tone for, understanding the course that you're on and how you got there. So it's great to kind of document these as well in your mission design document because it helps people understand, what other options might be a possibility for you and maybe also why you ruled out certain options as you were going through the definition process. This is actually something that Lee included, and I don't have a ton of the detail on this one, but you can kind of see from the high level of it an example of where a deployment failure really led to a NASA team having to rethink how to do things, try a different approach than they had originally planned for, leading to kind of a way to meet part of its objectives. So again, thinking about different options of how you might do something, get maybe not to full success, but part of the way there. These questions are repeated from the stakeholder focusing questions. But again, our key questions you can ask as you're looking for design drivers are off-ramps. What are the technology options for the payload or capability? What are the technology options for the constraints identified? What's the simplest approach we could take to get the information we need? And the key word that I want to highlight in all of these questions are options. If you're really coming up against a situation where you have zero options, that's a great time to ask why. Because again, we can be pulling out, why is that a driver then? Or what is constraining me that I don't have perhaps more than one way to approach this problem? As part of that flow chart, again, going through the trade studies and the iterative design loop, part of that is starting to look at your derived and allocated requirements. I'm not going to go into a ton of detail here because this is going to be covered in, I think, the next EAT, so Systems Engineering Part 2. You're going to dive in very deeply into requirements. But basically just want to point out that there are different types of requirements. We can have functional requirements. What does the system need to do? So this is not how. We have performance requirements. That's the how well. Does the system need to take measurements? We can have interface requirements, operational requirements, and then these ilities. So just pointing out a couple of them. Availability, how often, how long to take measurements. Reliability, maybe of your piece parts, survivability. So again, you're going to kind of go into detail about how to form requirements in the next round. What I want to kind of point out here about how this really relates to your mission design documents is that your system requirements review is going to follow fairly closely after SCR. And one of the things that I always find interesting or to try out is have your team read the mission design documents that you've created and individually come up with requirements and then bring them together to discuss and create your final list of requirements, because what that's doing is showing you where, number one, the mission design document might be open to too many different interpretations of what you're actually trying to do, or it'll allow for discussion of what is the real requirement you're trying to get after it. Regardless of how you do this, the thing to keep in mind with requirements is that your mission design document set and your RVM, so your requirements verification matrix, which you'll go over next week, should be consistent. This sounds really simple, but I've often seen teams that basically create both of them, but then use one of them as the primary and don't kind of keep them synced up. And again, as you're facing student turnover, which is definitely, it's going to happen for most of the teams here, or you're trying to kind of revisit why did this requirement come about, if you're having to rescope or make design choices, the mission design document is going to be that place that you go back to understand why. And so as you're going through that requirement process, again, you should be able to read through the mission design document, and especially with the high-level requirements, get this idea of where did that requirement come from. Read through the MDD and see, oh, this is probably the idea or the thread that led to that requirement. It will often directly be called out in the RVM, but that's not always the case. So again, look for consistency. ConOps, I like to think about as the how. You have the experiment plan that's talking about the what, and so concept of operations is really describing how the mission will achieve the objectives, and it's going to include everything related to flight, ground, and information systems. So how does the project get data or carry out the mission to satisfy stakeholders? You're going to have an EAT in a couple of weeks that goes into more detail, so just kind of highlighting a couple things here. SMAD does a great job of breaking out the elements of that. So that's going to include things like data delivery, your communications architecture, tasking, scheduling, and control, and your mission timeline. And so as you're building this up, this is a case where you're going to be going back and forth from experiment plan to ConOps and making sure that those are consistent with each other and that they are kind of informing each other in terms of what they need to do. And again, in I think 2 weeks, you'll have the EAT that really breaks down in detail how to approach building up operations. And next in that grouping of the flow is the idea of trade studies. So as you're looking for design drivers, you're looking for requirements, you're developing your ConOps, you're going to have to kind of go through trade studies as part of that process. And trade studies are really great to collect and document your choices, evolution of the mission. It's maybe why you went down one path versus another, and it really can be at any level of design. So it can be architectural. Why did you go for a 12 view versus a 6 view? It could be for a particular subsystem or a specific part, or even just with different vendor types for a given part. Generally, what you're going to be doing for trade studies is functionality and performance and trading those against schedule, cost, or feasibility. And you should outline, what are the must-have attributes versus items that can be traded. The inputs should be as quantitative as possible, but the evaluation of the trade study is often going to be qualitative. And so if we look at this table down below, you kind of just see a simple example of a trade study. And you can see the different kind of key features here. Again, what are the characteristics we're trading against? Functionality, performance, time or schedule, cost. Do it again at multiple levels, the architecture part or configuration. Let's just talk about it in the context of a part. So part 1 versus part 2. And then this idea of kind of commenting, what is the answer relative to, right? So for performance, part number 1 helps achieve 70% of objectives. Part 2 achieves 90% of objectives, and that's based on, the system budget you had analyzed. That's how you came to that, giving you some reference of where did that answer. You'll notice that there's some color coding in here too, in the sense of green, yellow, red. So green is, this is doing what it needs to do. I'm all good there. Yellow is, it's not quite doing what I need it to do, but it's accomplishing maybe a good chunk of that, or there's a workaround for it. And then red is, a big red flag in terms of unknowns, or could really cause a re-baseline of what you're going after. And so, again, going back to that statement of inputs, you want to be as quantitative as possible, but evaluation is going to be qualitative. What tables like this, or maybe more detailed trade studies, are doing is allowing you to have that conversation about the choices you have to make. Again, whether you need to re-baseline, maybe a stakeholder is okay with only 70% of objectives because you're going to save a ton in cost, right? Or it's within the budget. Now that we know what's possible or what's out there, we can set expectations appropriately. So it's that guide for having the conversation. And I'll just throw out there that it's great to reference trade studies in the mission design document sets if you don't include there. After you go through your initial iteration of the drivers, that iterative design loop, the ConOps, the requirements, you're going to kind of go to this next phase, which is really looking at functional and performance analysis. And then this other category is, does it work? Is it safe and reliable? Is it affordable? All of those boxes in that flow chart are really getting after the idea of feasibility. Is it feasible? So all of the content, all of the information that you've been building up as you've been going through that process are going to help you answer the question of, is my plan going forward? Is the way that I've defined my mission feasible? So looking at your design drivers is one of the great ways to determine feasibility. Looking at the system budgets you'll be building up is another great way to assess feasibility. So looking at your power budgets, data budgets, link budgets, all of that. And you might go through, as the slides show there, multiple iterations where you're starting out at a basic level and then getting more and more detailed over time. And then also, again, utilize those trade studies that you've been having to do along the way to compare the capability versus the need versus the constraint. All of that is going to give you that full picture of feasibility. And as you're doing that, you're going to come out with the idea of either, we're on track, we have a baseline that we've convinced ourselves and our stakeholders is going to work, or we have to have a conversation about how to adjust what our original plan was. So if we recap kind of all of that, all of the different pieces that we've talked about here, and why are we doing mission definition? It's helping us define and understand stakeholder needs. It's helping you know when are you done with the work that you've set out to do. It's helping you really understand, what am I going to be able to say by the end of this process? What have I learned? Where am I going to use what I've learned? All of those pieces. You've heard me mention the mission definition document, which is the way that we capture that information in you in several different times. So by SCR, you should have gone through this loop at least once and have a first baseline. And the emphasis here, again, is on convincing yourself that the mission is feasible. Obviously, you're going to get feedback from reviewers at SCR about things that you need to take into consideration, but you should go into it feeling like you have a feasible path forward. The other thing that I just kind of want to throw out as a very high-level comment is that there will always be some tension or some need to balance the time documenting versus the time doing, right? So you can have mission definition, and then there's that element of actually documenting your mission definition. There's no one right answer. Every team is going to take a different approach to both how they put the documents together and the level of detail that they take into account. But the one thing that I want to throw out there as you're starting out is, again, just this reminder that when you're trying to balance the doing versus the documenting, that, student turnover is something that most of you are going to have to address. And so having a very clean and clear set of mission design documents is going to help with that process. And then also documentation is one of the key ways that reviewers can help you. So reviewers, as you're going through your different review processes, aren't there to, judge you or to tell you, good or bad. They're really trying to help you understand, does your design close? How does this idea work? And so the documentation is one of the key ways that someone who isn't there with you on the day-to-day is going to be able to understand where can they give you advice or input that piece in mind. I think these slides are all provided to the teams, so we're not going to go through all of the next slides in a lot of detail, but Beth, if you advance one slide, what I want to show you is that there is an example if you wanted to see how a previous UNP team had kind of stepped through some of this process. You can get a feel for it. Again, they looked at those basic questions. What's the question you're trying to answer? What's the nature of the demonstration? What do we already know about it? They had a conversation about that and could kind of come up with, what is the story we're trying to tell here? Why is it important? They went to the next set of the questions. What did the physics of the question tell us about how they might answer it? What data or information do they need? All of those pieces. And this is all here in detail for you to be able to look at afterwards. So this is why I'm just kind of pointing out a few. So in the case of this former UNP mission, they had an equation that they could look to. Advance it one more time. And so before they had even envisioned, here is what my spacecraft is going to look like, or here's what I'm going to do, they could point out the key things of, what is already known, what can be measured, and what is being determined. And those are kind of those key elements where now you can play around with different solutions. Advance 2. So that they did their mission statement. Let's go to the next one. The thing that I want to point out on this slide right here is, as they were working through their objectives, one of the things they did was call out what are those related science questions. So I've been saying, what am I trying to learn, right, as one of those key questions. Sometimes having the question connected to the objective is helpful because it helps understand in kind of a different light how is the answer to that objective or that approach of the objective feeding in to some learning that is happening. So you can kind of go through what they pulled out from that. If you're looking for examples of what requirements, at least their top level ones, did they write their objectives, you can see some the last slide from the example set here. The thing that I want to point out with this, again, in the challenge as you're working through what is my concept, what is my idea, how am I going to do it, really challenging that idea that there is only one way to do what I need to do. Again, Dandy started with the idea of here's this equation, here's what we already know, here's what we need to measure, and here's what we're going to solve for. And the program actually ended up going through several iterations in their design. So you can see there they started with 3 deployable orbs and a mothership doing tracking. They had to ultimately change that because there were some ConOps challenges, they had sensor availability issues, and just even looking at what the team's capability was. And so, they had to really, again, think of what are some alternatives here. Also, you can see examples of, as they were going through their more detailed design, how their mission definition process, how they had to go through other iterations at the subsystem level. What they ended up with was this spherical, kind of see their final element of that. Again, it was this evolving architecture of how are they going to approach this, and what they ultimately ended up with was 90% of the mission, half the cost or risk. And so they were able to identify alternatives, have that conversation of, if I could give you 90%, is that good enough? Does this help us close the mission a little bit? So Dandy, you can go through in a lot more detail, and again, just gives you some sense of how another university tried that in the past. And that's the last thing I have. I know we've got a couple minutes left, so if we have any questions, happy to take them. Otherwise, I am looking forward to seeing what comes out of all of your mission design sets. Thank you very much, everyone.